We know that the energy of a body is its ability to do some work. This could also be understood by the work-energy theorem. We have already derived this theorem for a constant force. Let us now derive it for a variable force. We have learnt that for a varying force, the work done in one dimension can be expressed as a definite integral of force over displacement. W equals integral xi to xf fx dx, equation 1. We have also learnt that a moving body acquires kinetic energy. In this topic, we will relate the two concepts and prove the work-energy theorem for variable force. Let us consider the example where a block of mass is moved by applying a varying force Fx along the positive x-axis. The kinetic energy of the block is given as K equals half mv square, where m is the mass of the block and v is its velocity. Differentiating both the sides of the equation with respect to time, we get the following equations. Thus, we can write dk equals fx dx, equation 2. Consider that the block moves from initial position xi to xf under the influence of a variable force. The change in kinetic energy can be calculated by integrating equation 2 from initial to final position. Integral ki to kf dk equals integral xi to xf fx dx. Here, Ki corresponds to the initial kinetic energy of the block at initial position xi and Kf corresponds to the final kinetic energy at final position xf. Kf minus Ki equals integral xi to xf fx dx, equation 3. From equation 1, we can see that the RHS of equation 3 is the work done by the variable force. On substituting, we get Kf minus Ki equals W, equation 4. Equation 4 is the same as that for constant force. Hence, we have proved that the work-energy theorem holds true for both constant as well as for variable force. It states that net work done by forces on an object equals the change in the kinetic energy of the object. To summarize, the work done in one dimension can be expressed as a definite integral of force over displacement. W equals integral xi to xf fx dx. Work-energy theorem states that net work done by forces on an object equals the change in the kinetic energy of the object. Mathematically, it is given as Kf minus Ki equals integral xi to xf fx dx. Kf minus Ki equals W. Work-energy theorem holds true for both constant as well as for variable force. Whenever an object falls freely towards the ground, its kinetic energy changes due to the work done by the force of gravity. But what about its total mechanical energy? Stay tuned to find out.